So we are asked to graph three vertices and create a triangle from it, A, B, and C. A is at -4, -3. B is at -6, -1. And C is at -8, -5. So these are the points. And the very first thing that I'm asked to identify is what's the distance between points A and B? How far apart are they? So if I look at those, I could consider just this vertical change and this horizontal change. And when I focus on those, I can see that by focusing on the vertical and horizontal, I've created a beautiful right triangle. And this right triangle has a length of 2 there, and it has a length of 2 there. So I have this right triangle that has two sides that are both root 2, or both length 2. And that actually, that's interesting, because that is a 45, 45, 90 right triangle. I don't know. This thing could be an isosceles triangle. I think it is. But I'm just trying to find the length of AB. And I think it is 2 times the square root of 2. But I digress. So if we're trying to find the length of segment AB, we know that the length of segment AB squared, right? That notation means the length of that segment squared. It's not A times B squared. It's the length of segment AB squared is equal to 2 squared plus 2 squared is equal to 4 plus 4 is equal to 8. So it is equal to the square root of 8. And you can leave your answer like that. But that does have if some of you have calculators, you put that in, your calculator is going to say that's 2 root 2, because that's what it simplifies to. That's simplified radical form. So the answer for the first question there, what is the length of segment AB? The length of segment AB is the square root of 8, which just simplified to 2 times the square root of 2. And also as a decimal, what is root 8? I should know that. I'll hit second square root. Oh, no, what are you doing? Wait, let's get out of this thing. Second square root of 8. It's about I'll just round it to 2.8. About 2.8. All right, next. We are asked to reflect this triangle across the x-axis. Okay, so we're going to reflect this across the x-axis. Okay. Reflect this across the x-axis. What are the coordinates of B prime? Okay, so we're going to reflect this across the x-axis. So I can see where the x-axis is. I'm going to reflect across it. So when I do that, this piece right here that was at -6, -1 is going to go to -6, +1. So that's where that's going to go, right? And B is now kind of in the way there. I'll make this B. This is my B prime. Not B to the -1, B prime. That's the image of B. And then A is going to go, let's see, A was at -4, -3. It's going to go to -4, +3. -4, +3. So this is going to go to -4, +3. And this is A prime. And the last one, C was at -8, -5. So that's going to go to -8, +5. -8, +5. That right there. -8, 5, +5. That's C. So I got this new triangle that's living in here, and here, and here. That's great. There's the new triangle. It's reflected across the x-axis. So the question does say, what are the coordinates of B prime? So I know that B prime lives at the point -6, -1. It lives at -6, 1. And I like what they did, because they're asking me now, hey, look at B. You can see where the original B was, and look at this B prime, and notice that the x values didn't change. If I'm going to reflect across the x-axis, The x values stayed the same. They both stayed at -6, but look what happened with y. Y went from -1 to +1, right? Y became the opposite of what it was. So if I want to write a function that does a reflection across the x-axis, I can say if I've got any point xy, reflecting across the x-axis is equivalent to x staying exactly the same as it was, right? Doesn't change. In fact, all of those points, if you look at all of my points, their x values all stayed the same. A was still -4, B was at -6, and the C's are both at -8. So those stay the same. What happens, though, is the y values become the opposite of what they were, right? So this is the rule, for a beautiful rule, for the reflection across the x-axis.